Okay, I am going to start today by going back to Lab 2 and looking at that again. And if you have any questions about Lab 2 and some of the procedures that you need to carry out to do Lab 2, please ask them now. Any questions back there? Oh, you do not need to save the a.out file. Is that the question? Yeah. 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 What, all three of what? All three files? Oh, let me do it. I'm going to do the exercise again, and then you'll say. In fact, what I'll do is I'll do exercise 2. I'll do this exercise. We'll just do it as if we were doing a lab together right now. Okay. All right. So what we're going to do is we're not yet ready to work locally. Let's continue to work remotely by using SSH to connect to a lab machine. And we need to, once again, connect to a machine that's named jbh3-1.cse.csusb.edu. Log in. And so we're on JBH3-1, but we don't want to work on here. In fact, we can't work on here. The system administrator made sure of that. So we'll need to SSH to a lab machine. So that would be JB359 dash a random machine. I'll pick 3 today. Oh, look at this. Does anybody get that? See, you know, they reinstall the system in the lab a lot. And so what happens every time they do that, that part of that installation process involves generating a security credential. And you know, there's a private side to the credential that's just stored on the machine locally, and then there's the public side of the credential, which is distributed, meant to be made public. And we've cached the old public credential, and since that time, that the system has been reinstalled and a new security credential has been generated. So that conflicts with what we have in our cache. So I'm going to fix that. And I'm going to do that by going into this this folder. It's a hidden folder. It starts with a dot. That's why we don't see it when we list it normally. And there's a file in there called known hosts. You know, I don't know the difference between known hosts and known host 2. So I'm just going to guess my way through here. I'm going to look for what I believe to be, there's a JB359-1. See, I'm using a down arrow key here, so I'm jumping a whole line at a time. And here is, let's find it. There it is, JB359-3. I don't know when I logged into that machine. I think it was last year, last academic year, in the spring maybe. So I'm just going to delete that whole line and save. And now let's try it. Well, look at this. Now it's saying the authenticity, it's a different message. Right? It's not saying the security credentials have changed. It's saying that the authenticity of host JB359-3, and there's the IP address, the numeric address of the computer. This is the name, the human readable name. That the authenticity of this host can't be established. RSA key fingerprint is such and such. So this is actually the number. That's a number. Look at that. See, 28:E2. This is called a hexadecimal number. There's no character in there. Those are Those are decimal digits uh, mixed with the letters A through F. So those are the hexadecimal, that's a hexadecimal representation of a number. So you see a long string, and that's just a number. And that's in fact, that number is represents that host's public security credential. Are you sure you want to continue connecting? And I'm going to say yes. And now we're in. Let's see if anyone else is logged in. There is. Jay Mellon. Are you here? Oh, you're logged into that machine, right? See, we can all, there can be many people working on one machine at the same time. All right, so now let's go into our folder and look at what we've done. Well, we have two subfolders in our working copy folder. So CSE201 is called our working copy. It's the root folder of our working copy of our repository, or my repository, and then you have one that's a separate repository, your own repository. And we have two folders in there. Let's look at one. This one I believe we finished. There's a main.cpp in there. That's in the repository. And if we look at the other folder, oh, there's a main in there as well. Right? We put it in there to illustrate how that was done. And we can also see those in the repository. Let's go ahead and look at that. Oops. All right, so once again, I explained about the site security certificate not being trusted. It's a self-signed certificate, and it's not signed by a certificate authority that your browser is aware of, my browser, and yours too. So we need to accept that certificate, which is somewhat of an unsafe practice, just in case there's a man in the middle. It could be a man in the middle attack. Some man in the middle could be pretending that it is at this IP address right here. So let's see. I'm going to go in, I'm Turner. Now this is a different password than the password you use to log into the computer system. This is the password that you use to access your Subversion repository. And as you can see, there's the two folders. This is the file in the first folder. We just did that to illustrate how to use the read and write into the repository last time. So that's the beginning of a problem that we need to solve, and that the problem is described here in exercise 2. We need to write a program that displays this triangle. Is there any question at this point? No? Okay. Let's go ahead and write this program to solve this problem. And I have never solved this problem before, but it's a very easy problem. Let's see. Oh, I need to CD into that folder. Once again, when I do ls, I just see the file by itself. But if I were to do ls minus a, I'm saying show me everything. Show me the hidden files and the hidden folders. So there we see the .svn folder, and that contains information that the Subversion client program uses to help synchronize the working copy with the remote repository. Let's go ahead and fix this. And actually, I need to open up another let's just grab this stuff in here. So you're working in VI. See how convenient that is? I cannot use gedit in the console window. Gedit is a graphics program. You need a graphics window to work in. We have a local graphics window, but inside this local graphics window is just a console, is a connection that only allows text data to be transmitted through the network. So we cannot run gedit. And we tried that last time. Gedit fails. Oops. I wasn't paying attention to what I was doing. If we try to use gedit, cannot open display. So we can't find a display because we're running in a process that's not associated with a monitor, with a display. But we can use nano or pico. Was it pico or nano? I can't remember now. Nano. We can use nano, but this is not as fast as the program that I was just using called VI. Yeah, I'm going to use VI because it's, whoops, see that's my VI command there. I like to use VI, it's just easier for me. I don't need that blank line. One thing we talked about last time is the difference between this declaration of the main function and this declaration. And it's compiler dependent. I don't believe in the C++ specification that this is allowed. It might be. So it could just be allowed, optionally by compiler implementers. But this would be required by the language definition, I believe. Not 100% sure about that. So I'm going to go with this form. This is a more general form. And what this is all about is this is a function, and we're going to once again talk about functions a little later on, but I'm going to talk about them a little bit now. That you have what's called a list of arguments. This is the first argument, and then you have a comma here, and then the second argument. And the first argument is, the name is argc, and it has a data type called int. In other words, argc is a variable, and it is of type int or integer. So it's a variable that represents an integer which is stored in computer memory. And then the second argument is an array of char pointer. And that takes a while to explain, and I'm not going to get into it now, but basically what that is an array or a sequence. It is a sequence of string data. So a string is just a sequence of characters, like hello. That's H-E-L-L-O. That's the 5 characters. That's a string with 5 characters. There's a hidden byte at the end of that sequence, which is a 0. It terminates the string. It's not seen. So actually, in computer storage, you have not 5 characters, not 5 bytes, but 6 bytes. And that's assuming that you're representing the string using single byte character set. Could be that you're using a multi-byte character set, and then the string needs more computer memory to be represented. But in fact, this is a regular char. So the strings that are stored in this array, and that's saying things loosely because the strings are not stored in the array. It's the pointers that are stored in the array. I'm not going to get into that. But those strings are single byte characters. That's what a char is. If you see a W char, see something like W char T, that's a multi-byte character. We're using a single byte character here. Right? You need a multi-byte character set to represent many foreign languages, like Chinese. Right? And those kind of languages that have a lot of characters. All right, so What we want to do is print a triangle. Just going to get rid of this. Oh, and let me tell you, what are these strings that are being passed in? These are the tokens that are passed in on the command line when we execute the program. At this point, we're not going to use that. Maybe we use it later in the course. I can't remember whether we cover that. So let's just let's get this. Whoops. Let's just print something. Let's print one asterisk. Now I'm going to show you the technique. I'm not just going to solve the whole problem in one step. I'm going to do it incrementally, and I'm going to, throughout the course, I'm going to harp on that point and that technique, that when we solve these type of computational problems or computing problems, automation problems, that normally we do it in an incremental fashion. We do one step at a time. And part of the art of programming is to decide what it is that next step, what that next increment of development is going to be in constructing your solution to the problem. So I'm going to start by just printing an asterisk. I use C++. You can also use G++. It gives you the same result. So no problem. I typed in G++ main. That means it compiled. As you can see, we have a.out got generated. I'm going to delete a.out, and I'm going to show you what would happen if we had a mistake. Let's suppose that we didn't declare this correctly. Let's suppose we did this. S-return. This is a syntax error. The compiler does not understand S-return. It's going to say unknown identifier, something like that. It's going to complain. It's going to say, I don't know what S-return is. Let's see how it says that to us. This is how the compiler says that to us. This is how the compiler says, I don't understand S-return. In function, int main, error, return. Once again, there's a problem with the character set. That should be a quote, but it's coming across as a hat. And I should figure out how to fix that, but not right in this moment. Error. S-return was not declared in this scope. So there it is. It's complaining about S-return. So you need to read this. Even though you may not understand everything that's in there, that you should still read it carefully and look for clues that you can use to diagnose the problem, to solve the problem. And here's another clue. See the 8 right there? What is that 8? It's a line number. Line 8. That's right. And the 5 is a column number. That means is the 5th character on line 8. That's where the compiler noticed the beginning of a problem. It's not, by the way, the problem is not always where the compiler says it's having trouble. All right, so that's not a guaranteed way of finding the problem. It's just, but normally, if you just go to the location that the compiler is talking about, you'll locate the problem. And I'll show you an easy way to do that, at least in VI. We've got to look for the line 8. Let's suppose I was up here, and I'm going to search for line 8. In VI, you just do :8, and it goes to line 8. That's line 8. As you can see down here, look, line 8, 5. It even gives the character position, the 5th character in the line 8. So it shows it right in here, at least in VI. In Pico, it might show it as well, and so on. Most text editors show you the line and column position of the cursor. So you can use that to help spot these problems. Let's fix that. And let's rebuild. And once again, we have a.out. Oh, I forgot to show. I was going to show you that when you build it and there's an error, that a.out is not generated. But I'm just going to tell you that's what happened. There's the star. So we are one step on the sequence of steps that we need to do to solve the problem. Let's do the rest of the steps. What's the best way to do this? I'm going to do it like, I'm just going to do it my way. Want to do it your way? There's many ways to do it. And if you want to explain why starting on the bottom is better, we can listen to that proposal. But it, you know, and you might be right. But I'm just, you know, my intuition, and it says that I can do it this way. But I know I could start on the bottom as well. No, that's okay. It's good. I'm glad you brought this up. There are many ways to solve the problem. And you know, when the people working, you know, when you program, you're working in a team. You're working with other people. And there's constant proposals. Oh, wait a minute, I got a better way to do it. I say, okay, explain it to us. And then you have to basically convince the others that there is a better alternative. Well, sometimes there's not time to dig into that argument, right? And explain, and also to explain your position and explain why there's a better approach is sometimes difficult to do as well. Did you want to explain why starting on the bottom was better?
Because if you start at the bottom, you can put in those 6 asterisks with the spaces, and then go to the next line and put in a null string, and then go to the,
You know what? I got your idea. Let's do it. I think it's a good idea. All right, let's try it that way. Tell me if I do it wrong here, according to your suggestion, okay? So the bottom line, let's do the bottom line. Is this the bottom line? Do I put a space in there?
Yeah,
there's 6. 1, 2, 3, 4, 5, and 6. So that means, oh, I got an idea. How about this? How many lines are there?
There's going to be a line and then a space, a null string, a line and then a null string, a line and then a null string.
All right, let me try it like this. I'm going to do this. I'm going to do, how about if I just do it like that? Does that look good? Is this it? Well, that's not working. Huh?
You need a line with a null string in between each line that has asterisks in it. So
I need a line with a null string. Oh, with an empty, you mean an empty line?
yeah.
Oh, okay. A null string, a null string. Oh, you use the word empty string. I'm an old guy. I'm trained to use the term empty string. So a null string, I didn't quite register what that meant. But the standard expression is empty string.
Okay.
You need a line with an empty string. Okay. I thought when you said null string, I was thinking \n or something. I wasn't sure what you were saying, but now I understand. Let's do that. So we want an empty string. Actually, it's not really an empty string. It's just a string with a new line character in it.
But you have to have the amount of spaces all the way towards the end.
But there's nothing in that line, right?
Yeah.
Let me see. This is taking longer than I thought it was going to take. And I'm going to tell you, that is typical, right? Always takes longer than you think. So even with my original idea, my approach, it probably would have taken longer. So is this right for the bottom 2 lines? Or do you want to do something different than that?
You have to have spaces.
Huh?
You have to have character spaces where it matches.
Oh, so in other words, this is not correct. Is that right?
Yeah.
Like that, right? Is that right? Looks like that empty line, we don't need that empty line, right? Huh? Say it again. Take that empty line out? That's a comment, // I'm going to comment the line out because I'm not sure I want to delete it yet. I'm just going to comment it out. Let's build it and see how it goes. Is that getting there? Does that look good as the beginning, as a foundation, or is that not right?
Yeah.
It's good? All right. All right, so I'm going to get rid of that one then. So let's see. We're going to have to do something like, I'll do one at a time. Move that over one. Move that over two. And do the same here. Move that over one. Move that over two. Move that over one. Move that over two. And move that over one. We only need one. All right, that looks okay. I don't know, why do I have a space in here? I don't even need that space, right? That's not, no, looks nice and regular right now. That looks like it's going to work, right? Build it. Run it. We did it. All right, let's commit our work. And to commit, I'm going to go up. We didn't add any files. And I'm not going to add a.out. Let's take a look at the website again here. This is lab 022. I'm going to hit that refresh button. This is a start, so that's out of date. Let's commit. So I'm at the root folder of the working copy, and let's do a commit. And I'm going to put a comment in there. Looks good. Committed revision 4. And I'm going to reload that. There it is. That's our solution. Do you have a question about the subversion part?
Yes, but when you go back to the where you save the file?
Want to go back to here?
No, the next step.
On the web page back there.
Yes.
One page back? Like you mean this?
The web page where you go back.
Oh, the web page?
Yes. So in those you have the main.cpp.
Yeah.
Do you need
A.out?
Yeah.
No, I would prefer not to have it because I don't need that. But if you happen to commit it, it's okay. But I would rather have you omit the A.out. Yeah, normally that's
No, I have another question on that. So when I saved that one or when I committed that one, the second one, I also got a second file named main.cpp and there's like a curly thing.
Oh yeah, right. Let's see if that problem there. Watch this. I'm going to demonstrate that. Let's see if we can demonstrate it. I'm going to start this little screen program here. Uh-oh. It's not installed. It didn't install my favorite program. All right, so we're going to do it without screen. If you look in here, let's see how I can do that. Maybe I need to open up another terminal window. And if we use vi main.cpp, and then let's see if I can do that. I'm going to explain what's going on here. Let me open up. Can I do a duplicate session? Oop. Ay, ay, ay. My password. I gotta change my password now. That's not my whole password, but it's the beginning part of it. All right, so let's SSH to, actually we don't even have to SSH there. We can go right into to the folder. Oh, it's not there. Oh, see the dot main dot cpp dot swap? Is that what you're talking about?
Well, I didn't get the FWT. I got
Oh, all right. Now watch this. Watch this. Let's go back to this window. Wait a minute. I'm going to exit VI. And then see, this is a temporary file that VI created as a backup in case VI crashes. So if we look at, again, when VI exited normally, it cleaned up that temporary file. So what happened is Pico. Were you using Pico? Huh? Oh, gedit or get it. And Pico probably does something. Oh, I'm sorry, Nano. Nano does something similar, I would guess. Oh, it doesn't. Nano does not do anything similar. Maybe I need to modify something. Let me try that. No. So what's it called? Nano is not creating a backup, but gedit creates a backup, and it ends with a tilde actually. So let's control exit. I think what gedit creates is this. Is that right? That's what it looks like. So that's the naming convention that gedit follows when it creates its backup. So when you did a commit, either gedit was still open and running, or else gedit crashed, or you closed the window without, cleanly shutting down gedit, and so it left that backup. Or maybe gedit just leaves backup files around. Is that what gedit does? Does it just leave a backup files lying around?
well, it only happened on the second line when I moved the same program.
Oh. When you committed in the second one, was during that process of committing, was gedit still open? Yeah. So that's why you didn't give it a chance to clean up that backup file. So that would be an example of another file that you don't need to put in the repository. Don't worry about it. Well, if you want to delete it for me, I would appreciate it. And that's good practice to learn how to remove things from the repository. So yeah, you can do that. I'll show you how to do it. Well, first we have to add it. What is going on here? That tilde doesn't look right. Looks like it added it. So your situation looks like that, right? And what does it look like? It's got my uncommitted changes. See, I must have saved the file. I didn't want to save the file. All right, so what do we do there? We need to use svn remove. Is it remove? Maybe it's rm. svn rm tilde main.cpp. See, now it's scheduled to be deleted. I'm going to commit that. And by refresh, it's now gone. So you can use that rm, just like from the command line, you type in rm. Now let me show you something else here. And let's suppose that that we remove main.cpp. Okay? And we commit. Oh, I'm on JBH 3-1. I don't need that anymore. Let's go back to here. So we're going to do svn commit. But it didn't say anything, didn't do anything. Because we removed it in the using the Linux command rm, but we didn't do the removal through subversion. So there was no subversion. Subversion needs, if you're going to remove a file, you have to tell subversion about that removal. So actually, you tell subversion to do it for you. So as you can see, main.cpp is still in the repository, but it's not in our working copy anymore. So how do we get it in the working copy? Well, we can do one of two things. We can either get it from the back into the working copy, or else we can remove it from the repository. Let's show you how to get it back. Just run an update. Look at that. Restored main.cpp. That's kind of a nice backup system. You can even restore things to the state that they were in at previous revisions. So it's like an infinite undo. That's what you get with a revision control system like Subversion. You get this infinite undo. You have a complete history of all of the files and what they were like at each commit. Okay. What else do we need to talk about? Do you want to go over exercise 1? We did that last time, right? Okay. And let's see. Then we have the reading, and then lab 3 for next time. And but I've covered as much as we need to know to do what's due this week. So lab 2 is due tonight at midnight. You need to get that in. And maybe that's enough. I know it's a short lecture today. I could keep talking, but I doubt that you want me to just keep rambling on. So let's stop here, and then next week we'll pick up with the topics that are from reading 3, and we'll look at lab 3.